In today's class, I'll be talking about the new topic that is trigonometric functions. So, trigonometric functions. All right, so I'm going to start with the right angle triangle. A right angle triangle is a triangle in which one of the angle is 90 degree and the rest of the two angles can be of any degrees. Now, based on the right angle triangle, we can have the three trigonometric ratios. One is the sine theta, another is the cosine theta, and the third one is the tangent theta. So sine theta is always opposite upon adjacent, and cosine theta is no, sorry, opposite upon hypotenuse. I shall say. So this is adjacent upon hypotenuse, and then the tangent theta is opposite upon adjacent. These three trigonometric ratios which I have written, they can only be applied to right angle triangle. If the triangle is not a right angle triangle, I cannot apply the trigonometric ratios to them. Remember this concept. Now, if I draw a quadrant system, in this quadrant system, if this is called, first of all, this is first quadrant, this is second quadrant, this is third quadrant, and this one is the fourth quadrant. Here, all the angles are positive. All the trig ratios, shall I say, are positive. Here, only sine is positive. Here, uh, tangent is positive. Here, cosine is positive. So you can remember it as cast also. And I used to remember it as after school to college, or some people remember it as after I add sugar to coffee. Whatever way you wanted to remember it, you can remember it that way. Now, if I try and draw these trigonometric ratios on these on this quadrant system. So as I said, this is first quadrant, and x values are positive on this side, and y values are positive on the top, and x values are negative on the left hand side, and y values are negative on the bottom. So if I have to identify the point 2 comma 3, the point 2 comma 3 will lie. So it means I am moving 2 towards the horizontal axis and 3 on the vertical axis. So this is point 2 and this is point 3. So this will be the point. And if it becomes 2 minus 3, so 2 to the right, 1, 2 to the right, and then 3 to the bottom. So 1, 2, 3, 3 to the bottom. So this will be that particular point. Let's say I wanted to identify the sine and cosine values for this particular point. So this point 2 and 3, I'm going to draw a line from here. This becomes point 2 and 3, and then I will complete a right angle triangle here. So in this right angle triangle, the 2 is to the right and 3 is the vertical axis. So this is how it's going to look like. This is 2, this is 3, and I have to find this value. So if I find, how can I find out this value? By applying the Pythagoras theorem, that is 3 square plus 2 square, and then square root of that value. That will give me, let's say this, I'm going to call it as r. So this r value will come out to be 9 plus 4, which is square root of 13. It will be the r value. So this value will become square root of 13. And if I were to find out the sine theta value of, let's say this angle is theta, so sine theta value will be equal to opposite upon hypotenuse. And opposite value in this case is 3. So when I use the word opposite, it must be opposite to the given angle. So if I'm using this angle as theta, then this will become the opposite side. But right now I'm using this angle as theta, so this will become the opposite side. Hypotenuse will always be the longest side, so this is always hypotenuse. Now, opposite side will be, in this case is 3. 3 divided by square root of 13, that will be the value of sine theta. And if I were to find out the theta value, so theta will be sine inverse of 3 upon square root of 13. That's going to give me the theta angle too. So that's how we can find the value of a trigonometric ratio. Same way I can find out the tangent theta also. Tangent theta value will be again opposite upon adjacent, and then opposite is, again, if I go back and look into this one, the opposite is 3 and adjacent is 2. So the value will come out to be 3 over 2. That is tangent theta. Now, We said that the angles, the sign is positive in the all are positive in the first quadrant, all are positive in the first quadrant, sine is positive in the second quadrant, and then cosine is positive in this, and tangent is positive in the third quadrant. So what does that mean? I can prove it with the help of the same point. So if I take the point 2n minus 3, so 2n minus 3 will lie in this quadrant somewhere down here. So this means this point will be this x value is 2 and the y value is minus 3. So I can clearly see if I find out the cosine theta value is adjacent upon hypotenuse. Hypotenuse value, irrespective of you are in first quadrant, second quadrant, third quadrant, it will always be positive because you are finding it with the help of Pythagorean theorem. So hypotenuse value, if I call it as r value will be negative 3 square plus 2 square. That's going to come out to be again square root of 13 because negative 3 square will be positive. So if you're going to take any point in this direction, that's still going to be positive because square of any negative term is positive. So this value, r value, came out to be, whoops, I need to redraw it. I'll draw it. So this r value comes out to be square root of 13. So cosine is adjacent upon hypotenuse, which is 2 upon square root of 13. So I can clearly see the number came out to be a positive number. So same way, if you find any point here, then the tangent value will be positive because this is negative, both negative will cancel out each other. So this was a little bit about why the why all are positive here, only sine is positive, why tangent is positive, and why cosine is positive in this particular quadrant. Now, let's take some of the questions. I'm going to take one of the question as reference angle questions. So if I again draw the navigation system, and now I'll talk about two types of angle. First of all, principal angle, and then the second one is reference angle. All right, so now what is the difference between principal angle and the reference angle? So principal angle means if the angles, this is 0 degrees and this is 90, this is 180, and this is 270, this is 360. So principal angle starts from the 0 degrees, and wherever it ends, let's say if the angle is 270 degrees, so the angle ends here, so this angle becomes the principal angle. If the angle was let's say 330 degree, so again I'm going to start like this, keep on going like this, it will end somewhere in the fourth quadrant, so this will be principal angle. Now, if I talk about the reference angle is always with respect to the horizontal line. Whenever we are measuring the reference angle, we will measure it with respect to this line. So what do I mean by that? So if I draw the navigation system one more time, reference angle will be like this, or like this, or it will move like this, or it will move like this. So it can be this angle, it can be this angle, it can be this angle or this angle. So I can clearly see if you are in the first quadrant, then the principal angle and the reference angle are exactly the same. For example, if I take 45 degree as the principal angle, and then the reference angle for this principal angle will still be 45 degrees. Now, the situation changes if I'm in the second quadrant. Let's say if I take the principal angle as 120 degrees. So if I draw the 120 degrees in the second quadrant, it will be like this. So this is 120 degree, 120 degree. Reference angle, as I told you, has to start from the x-axis. If we are in second quadrant, it will start from this side. If we are in third quadrant, it will start like this. If we are in the fourth quadrant, it will start like this. If it is first quadrant, as I said, it will be the same as the principal angle. So now we are in the second quadrant, so we will start from this side. So now principal angle was 120 degree. So this with respect to this line, this angle will be 60 degrees. So how we calculated that? Because 180 degrees minus 120 degree will give me 60 degree. If you can visualize this, then it will be really easy for you guys to understand. So that's why I'm drawing the diagram with every question. So let's say the principal angle is 225 degrees, and find the reference angle for this one. So first of all, I'll draw the principal angle on the navigation system. I can clearly see the principal angle will be in the third quadrant. So this is principal angle. Now I wanted to find the reference angle. Reference angle will be this one. So this one was 180 degrees. So this is 225. So I can say 225 equal to 180 plus something in this scenario. So this value will be equal to, theta value will be 225 minus 180 degrees. That's gonna give me 45 degrees, and that is theta. In the previous one, what I did was, principal angle was 120 degree. I wrote it as 180 equal to 120 plus theta. That's what I wrote, because we were moving in this direction. I can clearly see from the diagram here that this angle is 60 degree. So that is my reference angle. I can clearly see this angle is 45 degrees. Okay, and same way, if it is 330 degree, let's say this angle is 330 degrees, I will move in which direction? In this direction. So this angle will become 30 degree, which is a reference angle. So again, just to compile it, reference angle is always measured with respect to the horizontal line in these direction. If you are in the third quadrant, you will move like this. If you're in the second quadrant, you will move like this. If you are in the fourth quadrant, you will move like this. If you're in the first quadrant, it will be same as the principal angle. So hopefully you were able to understand this concept. Now I'm going to start taking some more complicated problems with this. So now I'm going to take a question which is, uh, we are given a trigonometric number, and we wanted to find out the reference angle. Actually, wait a sec. Yeah. So let's look into this question. This question looks good to me. So a sine theta is given to me. Sine theta value is 0.2225, and the angle lies between 0 degrees and 360 degrees. This is the condition given to me. And what we wanted to find out, we wanted to find out theta value. So what is the theta value? Now, one of the things we need to also know that for this is, I wanted to find out theta. So if I put it in calculator, theta value will come out to be sine inverse of 0.225. So let me start my calculator on my phone. So it's going to take me a couple of seconds. So it will be second function sine inverse 0.225. Make sure your calculator is in the degree mode, so the angle comes out to be 13 degrees. So I figured out one of the angle is 13 degrees. So but the reality is, for every trigonometric ratio or for every angle, there will be I should say, for every value of a trigonometric ratio, there will be two angles. What do I mean by that? So if I ask you what is the value of sine 30 degrees, so you're going to say sine 30 is 0.5. And then I ask you sine of 120 degree also. So sine of 120 degree. So you're going to say sine 120, or let's say sine 1, not 120, I should have said sine 150. Oops, sine 150. That comes out to be again 0.5. Sine 150 degrees, 0.5. Now, if you are given sine theta equal to 0.5, now find the theta. You can say that sine can be 30 degrees, sine can be 30 degrees or 150 degrees. So same way, as I said, everything is positive here, only sine is positive. So sine has two positive values, one in the first quadrant, another in the second quadrant. Then tangent has two positive values, one in the first quadrant, another one is in the third quadrant. And cosine has two positive values, one in the first quadrant, another is in the fourth quadrant. So we can see also, if I put cosine 60 degrees, cosine 60 degree comes out to be 0.5. Let's say cosine 60, cosine 60 is 0.5, 0.5. And now if I say cos of 300, let me see, yeah, cos of 300 degrees, that is also 0.5. So again, if I put it cos theta equal to 0.5, what will be your answer? You're going to say theta can be 60 degrees, or it can be 300 degrees. It can be one of these two. Okay, that's why whenever we are given any value for any trigonometric ratio, there will always be two values. So hopefully you were able to understand that part of it. Now we figured out one of the angles. So how I'm going to find out the second angle, that's what we're going to see. So second angle we'll find out with the help of reference angle. So this is 13 degrees. So this was the, from this side I drawn 13 degrees, and second I'll draw, because sine is positive in the second quadrant, that's why I'm drawing it in this second quadrant. So I'm going to go 13 degrees in this direction, and that's going to give me the second angle. So the second principal angle will be this one. So 180 minus 13 degrees, 180 minus 13 degrees, that will be 167 degrees. So again, I will recommend you to pause the video and all find out the value for sine theta equal to 0.5, which we just did. So welcome back. So hopefully you figured out, and theta value will be, one is 30 degree from here, another 30 degree from here. So 30 degrees and this 30 degrees, and same way this angle will become 150 degrees. So 150, 30 comma 150 degrees. And if it was cosine theta uh, equal to 0.5, so theta value can be 60 degrees and 300 degrees. So how did we figure out that? So I can easily find theta equal to cos inverse of 0.5. That's going to give me 60 degrees first of all. So cos 60 degrees, 60, I will draw it like this. Another is this, where I'm going to ask myself where cos is positive second time. So cos is positive in the fourth quadrant. So I'm going to go like this. So this will be the second angle. So this is 60 degree down here. Whereas for the principal angle, it will become like this. So that's the value. So hopefully you were able to understand that how we figure out the uh, two values of the theta, and same goes for the negative also. So if I put it as cos theta equal to negative 0.5, so you're going to ask yourself, cos is negative in which two quadrant? Cos is negative in these two quadrants. So I'm going to draw it one more time. Theta value will be cos inverse of 0.5 negative. So that will be, let's see one more time, cos inverse, second function, cos inverse negative 0.5, which is 120 degrees. So theta value comes out to be 120 directly I got. Or you can, easier way to do this, if your calculator doesn't give you 120 degree, you just find out the positive value. You find out the cos inverse of 0.5, 0.5. So 0.5, positive 0.5, that will be 30 degree. But because we, what's our objective is negative. Negative is telling me it is in this quadrant. So this will be 30 degrees here. It, this 30, well, not 30 degrees, it should be 60 degrees. So 60 degrees, 60 degrees it should be. Okay, so 60 degrees I'm going to go in this quadrant, 60 degrees I'm going to go in this quadrant. So this will be, if I go from 180, this will be 180 minus 60, and this will be 180 plus 60. And so this will be, principal angle is 120 degrees, and 180 plus 60 will be 240 degrees. So let's see for what is the value for cos of 240. Cos 240 is again 0.5 negative. Okay, so that's how you can find out the angles. This negative and positive will tell you which quadrant you are searching the values in. All right, so hopefully you were able to understand this concept. Now I'm going to take another uh, complicated problem on this one. So if you are given tangent theta is equal to 2.05. Let's say this value is given to me, and theta lies between 0 and 360 degrees. This is another situation given to me, means we are only trying to find it between 0 to 360 degrees, and also says if cosine theta has to be less than 0. Cosine theta is less than 0. These are the two conditions given to me. We wanted to find out the theta value between 0 and 360 degrees. So cosine is less than 0. In which quadrant cosine is negative? I'm going to ask myself first of all. Cosine is negative in second quadrant and in the third quadrant. Tangent is a positive number. If I see tangent is positive number and it is less than 0, which quadrant fulfills that condition? Tangent is negative in this, so I cannot use the second quadrant because here tangent is positive value. I can see tangent theta comes out to be positive, so only quadrant left I'm left with is the third quadrant. Because of this condition, now I will have only one value, so it has to be somewhere in this. So I will find the theta equal to tangent inverse of 2.05 first of all, and let's see what's the value comes out to be. So tangent inverse, second function, tangent inverse 2.05, that is 63.99. So 63.99 as a principal angle, and I'll go 63.99 in this direction also here. So this is 63.99, and this whole angle will become 180 plus 63.99, which is 244 approximately, 244 degrees. So if this angle is 244 degrees here, so this is 244, and that will be my answer, because I cannot have the second angle, because the reason being I cannot, the cosine has to be less than 0. I cannot take this angle. Tangent is positive, although tangent is positive here also, but cosine has to be less than 0. So that's why I will only take my angle as 244 degrees. All right, let's look into one more question similar to this one, which is a little more on the trickier side. If we are given a question like cos of theta equal to negative 0.12. Now here, before I jump into this question, I wanted to tell you from exercise 8.2, make sure you guys do the question from 9 to 38. 9 to 38, they are very important questions, so make sure you do all these questions. And if you are struggling, come and see me in the tutorials in the library from Saturday 12 to 4. All right, so let me go back into the question now. So the question is cosecant. Cosecant theta is equal to negative 1.366 and cos theta is greater than 0. So this is the condition given to me. How I'm going to solve this? So cosecant theta. So we didn't talk about these ratios. So I'll talk about cosecant also. Cosecant theta, secant theta, and cot theta. Cot theta. Cosecant theta is reverse of or inverse of secant sine theta. So cosecant theta is 1 upon sine theta, and cosecant theta is secant theta. Shall I say this is cosecant, cosec, and secant theta is 1 upon cos theta, and cot theta is cos theta upon sine theta, or you can also write it as 1 upon tangent theta, 1 upon tangent, 1 upon tangent. I cannot erase it somehow. Okay, tangent theta. That's the relationship we have. Okay. Now, coming back to the question which we were doing, Cosecant theta we are dealing with. Cosecant can be written like this or CSC also. Both means one and the same thing. So CSC, cosecant theta is negative 1.366. I can write cosecant theta as 1 upon sine theta. 1 upon sine theta equal to negative 1.366. Now, if I wanted to find the sine theta value from here, what I can do is I'll flip them. I'll place 1 down here, bring this on top, and gonna make this on the bottom. So sine theta value will be equal to negative 1.366 upon, well, this will be 1 upon negative 1.366. So again, it takes long time to raise anything. So negative 1 upon 1.366. And now theta value, I'll try and find out the theta value. Theta value will be sine inverse of negative 1 upon 1.366. So let's see what's the value we figure out from here. So it will be sine inverse of 1 divided by 1.366. So theta value is, well, it has to be negative 1. I must write a negative here. So negative 47 degrees, negative 47 degrees. Now I'm going to ask myself a question. So here, this is, see it carefully. Sine is negative in which quadrant? Sine is negative in third quadrant and in fourth quadrant. So these two can be my answers. However, another condition is given to me, cos theta is greater than 0. So means cos is positive in which quadrant? In the fourth quadrant. Cos is negative in the third quadrant. So in the third quadrant, cos theta is less than 0. But in fourth quadrant, cos theta is positive. So cos theta is greater than 0. So I will take only the value which is in the fourth quadrant. So negative 47. So how I'm going to draw the negative 47? So this will be negative 47 degrees, and this will be the angle. So if I were to look into the principal angle, this will be 360 minus 47. That's going to be 313 degrees approximately I'm using. So this is, if I see sine of 313 degrees, that is a negative value, which is equal to 1 divided by 1.366. Yeah. So let me just check the answer for this question right at the end of the book also. I'm doing question number 35 from 8.2. Question 35 from 8.2. Hopefully I will get the right answer, because I don't want to make this whole video again. 8.2. So if I go to chapter 11, 10, 9, 8.2, question 35. Yeah, they figured out as 312.95. I took it approximate 313 degrees. So that's how we're gonna solve these questions. So hopefully you were able to understand this topic, how to solve these questions. And let me just quickly look into 8.3 also. If I were to ask you, yes, okay, I'll quickly tell you about how to convert the degree into radians, and this is what you need to do from this. You don't need to do too much. How to convert radians into degrees, radians to degrees, and degrees to radian, degree to radian. How you going to convert? So if you are given 30 degrees, how you can convert it into radians? So 30 times pi over 180, because you wanted to convert it into pi form, so pi will be on top. So 30, you can reduce it to 60, so pi over 60 will be the value when you convert 30 degrees into radians. Now if you are given pi over 6, well, if you are given this number, you can again reduce it also. Pi is 3.14, 3.14 divided by 60 also. So you, well, this is not 60, this is actually 6. This is 6. So pi over 6. So 3.14 upon 6. Whatever number you get, you can write it like that also. So if I were given pi over 6 converted into degrees, so pi over 6 multiply by 180 over pi. That's how you can convert it. So pi cancel out. This is going to give you 30 degrees. So that's how you convert degree into radians and radians into degrees. So try and do question number 3 to question number 3 to question result significance. I'm just checking which question I can give you. Express the into radians measure degrees. Okay, that's fine. You can do up to question number question 34, 3 to 34. Okay, mainly if I were to ask you, try and do 3 to 18. That will be sufficient, but if you wanted to do it in detail, you can go up to 3 to 34. So that will be from chapter number 8, and that's it from chapter 8, and then I'll see you another video. Till then, goodbye.